12 scientific facts that prove you don't understand reality. 85% of the universe is missing. We can weigh it in galaxy rotations. We can see it bend light around clusters. We can track its fingerprints through the cosmos, and we still can't find it. We call it dark matter, but that's a label, not an answer. If most of reality is invisible, what else are we wrong about? I've pulled 7 facts that don't add up. Each one breaks a rule you thought was solid. Institutions can measure the effects, but not the causes. Watch for the pattern, time slips, space tears, choices blur. Let's start with the invisible mass that shouldn't exist, except it does. Fact 1, dark matter isn't there, but it is tightened. Here's the cleanest way to see the problem. Take a spiral galaxy. Stars far from the center should orbit more slowly, the way planets farther from the sun move slower. That's what Newton and Einstein predict when you tally up the visible mass. But when Vera Rubin and Kent Ford measured rotation curves in the 1970s, the speed stayed flat, too fast in the outskirts. It's like the galaxy's outskirts are gripping a hidden handle. The math says there's way more mass than we can see. Now switch lenses literally. Gravitational lensing lets us map mass by how it warps background light. In cluster after cluster, the strongest lensing happens where there isn't enough luminous matter to account for it. The showpiece, the bullet cluster 1E065756. 2 clusters collided, gas slowed, but the lensing peaks tracked the galaxies, implying most of the mass barely interacts except via gravity. Something is there, not shining. Why this matters is simple. Our cosmology collapses without the missing mass. Structure in the early universe wouldn't grow into galaxies on time without a gravitational seed that doesn't pressure couple with radiation. Simulations with dark matter produce the web-like cosmic structure we actually observe. Take it out, and the universe looks wrong. But watch how we respond. We measure consequences and name a cause. So physicists tried to find the stuff. The classic pitch, WIMPs, weakly interacting massive particles born naturally in early universe thermodynamics. Build ultra-clean detectors underground, wait for a tiny recoil. Decades later, LuxZ-PLIN, Xeno NNT, PandaX, and others report null results that squeeze the parameter space. The WIMP miracle looks less miraculous. Okay, so maybe not WIMPs. Axions, ultralight particles that could solve the strong CP problem, and if they exist, act like a cold, diffuse fluid. Haloscopes ADMX and beyond tune microwave cavities through frequencies, listening for axions to convert into photons in a magnetic field. Hints, not yet. We push sensitivity, rule out ranges, keep going. Sterile neutrinos, they'd slip past the weak force and only show up gravitationally, tweaking X-ray lines and cosmology. Claims appear then fade. The chase continues. Meanwhile, some say the problem isn't new matter, it's old assumptions. Modified Newtonian dynamics, MOND, tweaks gravity at very low accelerations so galaxies rotate the way we see without extra mass. MOND fits many rotation curves with one acceleration scale, but struggles with clusters and cosmology unless you add patches. Relativistic MOND and other modified gravity frameworks try to match lensing and the CMB, but none is standard. Notice the pattern, negative space phenomena. Dark matter is defined by what it isn't, no light, no charge, no strong interactions, yet it rules motion on the largest scales. We're fitting the universe to our math and instruments, not the other way around. That's okay, science often works that way, but it should lower our confidence in what solid means. Here's a detail people miss. In galaxies, dark matter seems to form halos with cores or cusps depending on the system, and baryons, normal matter, can heat and stir that halo through feedback from star formation. So even invisible matter is sculpted by the visible. The separation isn't clean, it's a relationship. In merging clusters, the dark component sails through, but in dwarf galaxies, small-scale structure hints at something warmer or self-interacting. That nudges models toward particles that talk to themselves weakly, changing halo shapes without lighting up. Remember the bullet cluster. There are messier systems like Able 520, the train wreck, and El Gordo where mapping is complex. One exhibit is powerful, population studies test the rule. So far, lensing surveys still demand extra mass while hinting at tensions. Matter clumping from weak lensing, S8, runs slightly lower than CMB inferred values. Either subtle systematics haunt our measurements, or the dark sector is richer than a single cold fluid. What's crazy is how comprehensive dark matter's fingerprints are. It stabilizes galaxy disks, anchors halos, sets up the scaffolding for gas to cool and form stars. Yet every direct search has come up empty. That puts us in an awkward spot. The universe behaves as if an invisible mass dominates, and our detectors insist they don't see it. When evidence and absence both stack up, you've hit a boundary. The deeper pattern emerges. We're repeatedly forced to accept invisible causes because the consequences are undeniable. In art, negative space defines the figure. In physics, these absences define the rules we trust. If mass can be invisible and still steer galaxies, check your confidence in everything that feels tangible. Speaking of invisible forces shaping everything you can see, the universe isn't just held together by a hidden mass. It's being pulled apart faster and faster. If mass raises questions, the acceleration raises alarms. If all this space is expanding, what's doing the pushing, and into what? Fact 2, dark energy breaks the map of the future. Okay, invisible mass holds things together. Now meet the invisible pressure tearing everything apart. In the late 1990s, two teams used Type Ia supernovae as standard candles, expecting to see expansion slowing under gravity. Instead, distant supernovae were dimmer than slowing predicts. The only way to square that, expansion is speeding up. Space itself acts like it has negative pressure. We call the driver dark energy. Again, that's a label, not a substance we've bottled. The cleanest summary lives in lambdictum, cold dark matter plus a cosmological constant lambda, a uniform energy density built into empty space. Plug lambda into Einstein's equations and you get accelerated expansion that fits supernovae, the CMB's geometry, and baryon acoustic oscillations. On paper, it's consistent. Under the hood, the numbers are absurd. Here's the mismatch that keeps theorists up at night. Quantum field theory says the vacuum isn't empty. It's a sum of zero-point energies of every field. Add them up with any reasonable cutoff and you overshoot the observed dark energy density by about 120 orders of magnitude. That's the cosmological constant problem. Right sign, wildly wrong size. You can fine-tune to cancel most of it, but at one part in 10^120. So 3 roads, none paved. 1. Vacuum energy really is a constant with a finely tuned tiny value. 2. It's not constant. Some dynamical field, call it quintessence, is rolling slowly, mimicking lambda today but changing over cosmic time. That gives you a time-varying equation of state parameter W slightly different from -1, which surveys are hunting by mapping millions of galaxies and supernovae. So far, W hugs -1 within current precision. 3. Maybe gravity itself is different on the largest scales. Modify Einstein instead of adding new stuff. F, R, gravity, scalar, tensor theories, massive gravity, brane worlds. These models tweak curvature's response to stress, energy to get acceleration without a pure lambda. But then you must pass solar system tests, binary pulsars, gravitational wave speed constraints, and cluster dynamics, while matching CMB anisotropies. Most candidates get cornered or require fine-tuning. Notice how the universe keeps rewarding stability with exceptions. Matter clumps. Dark matter made sure structure could form early. Dark energy does the opposite. The more it dominates, the faster everything dilutes away from everything else. Turn the clock forward and galaxies outside our local group disappear beyond any possible signal. The map of the future isn't just lonely. It's undefined by our usual guides because the ruler and clock are tied to a geometry being stretched faster and faster. Here's a subtlety. Acceleration is inferred by comparing distances and redshifts across time. Systematics matter. Are Type Ia supernovae truly standardizable across redshift, metallicity, dust? Surveys have tightened that. Distance ladders and H0 calibrations spark the Hubble tension. Local measurements versus early universe inferences don't match perfectly. Weak lensing's S8 comes in slightly low compared to lambdictum forecasts from the CMB. Either reductions are tricky, or the dark sector has more knobs than one constant and one particle. If dark energy is a field, where's its mass scale, couplings, and why hasn't it shown up in lab tests of fifth forces? Screening mechanisms try to hide it in high-density environments and reveal it cosmologically, chameleon, symmetron, Weinstein effects. But every success adds a moving part. If it's a true constant, why that value now? The coincidence problem. Why is dark energy density comparable to matter today, not overwhelmingly tiny in the past or utterly dominant long ago? Anthropic reasoning shrugs. In a multiverse of different lambdas, observers arise only where structure forms. That selects small lambda. Testable. Barely. Satisfying. Depends on your appetite for selection effects as explanations. What's crazy is how many independent rulers point to the same acceleration. Supernovae brightness, bow standard rulers, CMB angular diameter distances, galaxy clustering growth rates, even gravitational lensing statistics. You can swap techniques and telescopes. The pattern holds. It isn't a single instrument's bias, it's the sky's. That's why institutions agree on the effect and disagree on the cause. The deeper pattern returns, fine-tuning everywhere. Dark matter saves structure formation, dark energy dissolves it. Two invisible hands, opposite directions, both tuned to matter-era scales. We keep replacing mechanisms with parameters and hoping the universe explains our choices later. So far, it hasn't. If space can accelerate by itself, then geometry isn't passive background. It's an actor with its own energy bookkeeping we don't understand. Push to smaller scales and the strangeness spikes. Because when you zoom in far enough, space doesn't just stretch, it stops behaving like space at all. Fact 3. Quantum entanglement violates your intuition about distance. Okay, space can stretch, but here, that's where between stops being useful. Einstein, Podolsky, and Rosen tried to corner quantum mechanics with a simple move. If measuring one particle instantly tells you something about a distant partner, then either influences travel faster than light, or the particles carried per-written answers, hidden variables. That's the EPR paradox. The idea was to show quantum theory incomplete without those hidden instructions. John Bell turned that philosophical jab into a test. He derived inequalities that any local hidden variable theory must satisfy. Then experimenters asked entangled particles the questions Bell prescribed. Choose measurement settings on each side, compare correlations, and see whether nature obeys the inequality. Decade by decade, the loopholes closed. Detection efficiency, locality separation, freedom of choice. In modern, space-like separated, loophole-free experiments, 2015 and after, the correlations violate Bell's bound. Local hidden variables are ruled out statistically. Why this matters is sharp. Relativity caps signaling at light speed. Quantum theory respects that entanglement can't send messages, yet the outcomes are more correlated than any local story allows. The spooky part isn't superluminal information. It's that the joint facts don't factor into parts with their own independent properties. Separate systems don't carry fully separate realities for those measured quantities. Watch what to look for. Entanglement swapping, entangle A, B, and C, D, then a joint B. C measurement entangles a D, quantum teleportation. An unknown state reappears elsewhere using shared entanglement plus a 2-bit classical message. And device-independent cryptography, security certified from Bell violations without trusting device internals. These are working protocols. Notice how this collapses separate as a reliable idea. You can space stations a continent apart, time their choices to be random and near simultaneous, and the statistics still demand a non-local structure. Not faster than light signals. No knob you turn here changes marginal probabilities there, but a deeper constraint linking outcomes as if the questions are asked on a single, distributed object. The pattern we keep hitting shows up again. Relationships first, properties second. Okay, but what about loopholes? Experimentalists anticipated that. They closed the locality loophole by ensuring the choice of measurement on one side can't causally influence the other within light cones. They closed the detection loophole by improving efficiency so you can't cherry-pick detected events. They improved randomness sources to protect against subtle correlations. Every time the tests got stricter, the violations persisted. If you want to keep local realism, you're pushed toward conspiracies, superdeterminism, where the universe pre-correlates measurement settings with hidden variables. That rescues locality at the price of undermining experimental independence. Maybe, but it's a steep cost. Here's what's crazy. Entanglement isn't rare or delicate in principle, it's the typical state of composite systems. In quantum many-body physics, entanglement patterns classify phases of matter. In quantum computing, entangled qubits are the resource for speedups. In condensed matter, topological order and error-correcting codes are entanglement architectures. The spooky is also engineering. Now connect this to earlier themes. Dark matter connected masses through gravity without light. Entanglement connects outcomes without signals. Invisible causes again, but now they're constraints on joint probabilities, not forces in space. It's a different kind of glue, one that doesn't push or pull, but restricts what can happen together. Remember this detail. In quantum field theory, locality means operators at space-like separation commute, no causal influence. Yet the vacuum itself is highly entangled across any boundary. That's why cutting space, say, tracing out a region, produces thermal-looking mixed states on the remainder. The thermodynamic flavor isn't an analogy. It falls out of tracing over entangled degrees of freedom. The boundary holds information about the bulk because of entanglement. a hint we'll need when spacetime itself starts to look emergent. This next one takes it further by breaking our comfort with order in time. In delayed choice entanglement swapping, you can decide to perform the joint measurement that entangles A and D after A and D were already detected. The correlations adjust as if the classification of what happened depends on a choice in the experiment's future light cone. There's no contradiction, no retrocausal signal. But the classical story, first events fix later outcomes, strains, and a geometric view of correlations starts to feel more natural than a chronological one. But wait until you see how we've weaponized this. Quantum teleportation moves states, not stuff. Quantum key distribution uses entanglement monogamy. If an eavesdropper shares entanglement with your pair's correlations weaken, and you catch it. Device independence means the very strength of Bell violation bounds the extractable randomness and secrecy. We're turning philosophical anxiety into certified resources. The pattern here is clean, a non-local structure underneath local appearances. The map is a network of constraints. The territory is what satisfies them. Space is a helpful coordinate system, but it isn't the whole story of what goes with what. If separation is questionable at the quantum level, what about the other absolute we lean on? A single, shared now. Entanglement already hints that slicing reality into independent parts is a choice, not a fact. Time is about to get the same treatment. Fact 4, time dilation says there is no single now. If entanglement messes with between, relativity messes with when. Start with the rule that actually works your phone. GPS only works because we correct the clocks. Satellites are higher up where gravity is weaker, so their clocks tick faster. They're also moving relative to you, so special relativity makes them tick slower. Add both effects, and if you didn't fix the rates, your maps would drift by kilometers per day. That's not philosophy. That's a patch Tuesday for reality. Why this matters? Simultaneity isn't universal. What counts as now for you is now for me if we're moving differently or sitting in different gravitational wells. Einstein's point was time is an illusion. It was tighter. Time is a dimension stitched to space, and motion bends how you slice it. You live in a sequence of space, time events, your world line. Another observer slices that four-dimensional loaf at a different angle. Their present cuts a different set of events than yours. No single global now survives that geometry. Watch for 3 anchors. First, the twin paradox. One twin stays on Earth, the other accelerates, cruises near light speed, then returns. On reunion, the traveler is younger. There's no contradiction because the world lines aren't symmetrical. Acceleration breaks the mirror and carves unequal lengths of proper time, the time measured along each path by each twin's own clock. Second, gravitational time dilation. Clocks tick slower deeper in a gravitational field. Put one on a mountain and one at sea level, they diverge. We've measured that with atomic clocks, planes, even lab-scale height changes. Third, black hole horizons. As you hover closer to a horizon, time stretches so severely relative to faraway observers that your processes slow to a crawl in their coordinates. To you, your own time feels normal. That mismatch is the point. Here's the geometry payoff. In relativity, causality is literally a shape, the light cone at each event. Anything inside your future light cone can be influenced by you. Anything outside can't be, regardless of how you boost your rocket. Causality becomes a map constraint, not a metaphysical rule. That's why we keep saying causality is geometry. The order of before and after for space-like separated events can flip depending on who's moving. If your now can't be everyone's, then what exists right now becomes observer-dependent too. Notice the pattern meeting entanglement halfway. We already saw that the vacuum's entanglement makes subsystems look thermal when you trace out the rest. In curved space or accelerated frames, that becomes the UNRRA hint. Accelerate hard enough and the vacuum looks like a warm bath. Whether particles are there depends on your motion. Measurements aren't passive. They define which slice you're calling real. Okay, but does this wreck cause and effect? No. The prohibitions stay intact. No signal outruns light and local dynamics stay consistent. What dissolves is the idea of one cosmic clock. Even everyday tech betrays this. Fiber networks and stock exchanges synchronize clocks with relativity corrections or lose money. Your wristwatch is parochial. The universe doesn't endorse it. Remember this detail that feels small but isn't. In general relativity, mass and energy tell spacetime how to curve, and curvature tells matter how to move. Clocks aren't innocent bystanders. They're part of the geometry. That's why GPS works only when you solve Einstein's equations well enough to correct the orbits and the rates. The present in those systems is a convention chosen to keep the network coherent. not a discovery of a universal slice. Now push to extremes. Near a black hole, tidal gravity can stretch time so dramatically that infall looks frozen to a distant observer, while the infaller experiences a quick, finite plunge. If you film both stories and compare later, they don't stitch into a single shared now. You reconcile them by respecting the cones. That's also why horizons trap information flow. For an outside observer, signals redshift and fade. For the infaller, they scream by. Same physics, two slices. What's crazy is how much this reframes everyday statements. At the same time, across the galaxy is a choice of coordinates, not a fact. If you want a clean now, you pick a slicing, say, one that follows the average cosmic rest frame defined by the microwave background. It's useful but not sacred. Change the slicing and stories reorder without breaking causality. The deeper pattern is back. Observer dependence isn't a glitch, it's structural. Non-local ties in quantum theory made separate unreliable. Relativity makes simultaneous unreliable. Your present isn't mine, and neither of us is wrong. We live in slices of a four-dimensional constraint network, and what we call cause is the path we trace through it. So if time bends and now is negotiable, why does experience still flow one way, from remembered past to felt present to open future? The equations don't care. That arrow is coming from somewhere else. Fact 5, the arrow of time shouldn't exist, but it does. Here's the tension. The microscopic laws, the equations for particles and fields, run just as well backward as forward. Flip the velocities, change t to minus t, the math doesn't flinch. But your coffee cools, never heats itself. Eggs shatter, never unshatter. Memories point one way. Where did that direction come from if the rules don't care? The standard answer is entropy, the number of micro-configurations that look the same at our coarse, macroscopic level. High entropy means more ways to be arranged. Low entropy means fewer. Systems wander from rare, ordered states toward common, disordered ones simply because there are vastly more ways to be messy. That's the second law, but look closely. Nothing in fundamental dynamics forces that trend. The trend appears if you start from low entropy. So the real puzzle moves back a step. Why was the early universe in such a special low entropy state? The microwave background is astonishingly uniform to 1 part in 100,000. Gravity makes the story weirder. For gases, uniformity is high entropy. For gravity, uniformity is low entropy because clumping, forming stars, black holes, opens far more microstates. That means the smooth beginning was extraordinarily ordered by gravitational standards. We've been rolling downhill ever since. Watch for the tools people use to probe this. Fluctuation theorems quantify how often small systems momentarily buck the second law. Entropy can go down briefly, but the odds scale exponentially against big, long-lived decreases. Boltzmann's brain is a thought experiment that pushes the logic to absurdity. If you wait long enough in an eternal thermal bath, random fluctuations will occasionally assemble a self-aware brain with false memories. That's a reductio. If your cosmology predicts that typical observers are fluctuation brains, you've built a world that explains away experience rather than grounding it. Inflation often shows up as a patch. A scalar field rolls slowly and exponentially irons out curvature, defects, and inhomogeneities. Quantum fluctuations seed structure after inflation ends. It's powerful, but not a free pass. You still have to ask why the inflaton started in the right place with the right properties, and whether inflation sets initial conditions or reframes them. The low entropy question sneaks back in. Notice the pattern we keep using. We explain the arrow with a boundary condition, not a dynamical law. We say, given an extremely special past, typical evolution goes toward higher entropy. That's true. But why that past? One move is the past hypothesis. Stipulate that the universe began in a very low entropy macrostate. Full stop. It's clean, but it's a label on the mystery, not a mechanism. Here's an angle that links to quantum theory. When you ignore degrees of freedom, trace out the environment, subsystems look mixed, often thermal. Entanglement growth in an isolated quantum system makes local observers see entropy rise even when the global state evolves unitarily and time-symmetrically. The arrow shows up when you choose a tensor product cut and a coarse graining. That sounds like a cop-out until you notice it mirrors how we live. We're local, finite, and constantly discarding information into the environment. Now fold in black holes. Toss in a bookshelf's worth of ordered stuff. The horizon area increases, encoding a staggering entropy. Hawking's calculation says the whole radiates thermally and evaporates. Where did the information go? If it's lost, quantum evolution isn't unitary. If it's preserved, it must be smeared in correlations across the radiation in a way no simple thermometer sees. The modern take favors preservation. Page curves, island formulas, and holographic calculations suggest unitary evaporation with subtle entanglement patterns. Either way, the arrow is loud. Horizons hide, areas grow, thermal spectra dominate. It screams one way even as the fine-grained bookkeeping stays reversible. Here's the detail people miss. The arrow you feel isn't just thermodynamic, it's psychological and computational. Brains are low entropy, out-of-equilibrium organs burning energy to form stable memories. Writing to memory increases entropy in the environment. You remember the lower entropy past because the records were created then. That's not circular, it's a constraint. Reliable records require free energy and dissipation. Your sense of flow is the byproduct of error-corrected snapshots laid down by irreversible processes. What about reversing the movie? In principle, you could arrange an astronomically precise state that unmixes the cream. Practically never. Any noise ruins the path. The second law is about overwhelming odds, not logical necessity. Maxwell's demon failed once Landor showed erasing memory costs energy and increases entropy. Clever bookkeeping doesn't beat statistics. Pull back to the cosmos. Two arrows dominate your fate. Dark energy stretches space, thinning matter and isolating islands of structure. Entropy climbs as stars burn, planets cool, black holes gulp and glow. Given enough time, protons may decay, black holes evaporate, and only thin radiation remains. That's the quiet end. A cold, dilute universe where almost nothing happens because almost everything already has. So the equations don't care about direction, but the world we inhabit clearly does. The fix isn't new dynamics. It's recognizing that arrows come from improbable beginnings plus typical evolution plus relentless coarse graining. We keep outsourcing the improbability to the past, and we still can't look back far enough to check. Fact 6. Observation changes the thing observed. We just said the arrow you feel comes from coarse graining and records. Now flip the microscope. What counts as a record at quantum scales? Start with the double slit. Fire single electrons at two openings. If nothing asks which slit, the screen builds an interference pattern, bright and dark bands. Insert a which path detector and the bands vanish. Same electrons, same slits, different question. Outcomes reorganize around what's knowable. Why this matters isn't mysticism, it's bookkeeping. The quantum state encodes possibilities and their phases, the ingredients that let alternatives add or cancel. When information leaks about which alternative occurred, those phases stop lining up across branches. Decoherence spreads phase relations into the environment's countless degrees of freedom, effectively hiding them. To you, interference disappears. It looks like a collapse, even if the underlying evolution is still unitary. Watch for 3 key moves. First, decoherence isn't a hand wave. You can model a particle entangling with air molecules, photons, or a detector. Off-diagonal terms in the density matrix, phase-sensitive coherences, get suppressed in the basis the environment monitors. That picks a pointer basis, the stable set of outcomes that behave classically. Second, measurement is interaction. There's no telepathy. You couple system and apparatus. Their joint state branches into correlated terms. Third, amplification. A microscopic event flips a metastable detector, triggers a cascade, writes to memory. That's how a microscopic possibility becomes a macroscopic fact. Okay, but what is the wave function? Here the forks appear. Many worlds, no physical collapse, only branching. Decoherence keeps branches from interfering, probabilities are branch weights. Objective collapse models, GRW Penrose style, add a stochastic law that makes superpositions of massive states spontaneously localize, tuned so atoms stay quantum but tables don't. Psi-epistemic views treat the wave function as knowledge, collapse is updating information. Cubism pushes that, quantum states belong to agents. Notice how each fix shifts the burden. Branching worlds keep unitary math and pay with an extravagant ontology. Collapse models keep single outcomes and pay with new, unobserved dynamics you must hide from precision experiments. Epistemic models keep modest ontology and pay by explaining Bell-type constraints on information while avoiding hidden variable traps. There's no neutral choice. Your preferred poison signals what you think real means. Here's the subtlety everybody rephrases but few sit with. Decoherence explains why interference vanishes in practice and why classicality emerges for macroscopic records, but it doesn't by itself pick one outcome. It solves the preferred basis problem robustly. It doesn't solve the problem of outcomes. That's where your interpretation walks in. The data don't force one, your metaphysics does. Institutions can engineer quantum cryptography and sensors either way. Philosophy still has to choose. Tie this back to entanglement's geometry and the arrow of time. When a measurement happens, you're carving the world into system, apparatus, and environment. That cut isn't given by the equations. It's a modeling choice aligned with how interactions actually factor. Once you cut, tracing out the environment yields a mixed state. Entropy rises for the parts even if the whole stays pure. The collapse, you see, is exactly the loss of access to phase information. Records are irreversible because you spread correlations into places you won't gather them back. Now what to watch in labs. Weak measurements gather partial which path information and show interference fading smoothly. Quantum erasers scramble which path information so it's unlearnable, recovering interference in subensembles, even in delayed choice setups. No retrocausality, just conditioning on available correlations. Device-independent protocols use Bell violations to certify random bits and secret keys without trusting device insides. The measurement problem becomes a resource. Macroscopic superpositions aren't just cartoons. Interference fringes with giant molecules, superconducting qubits in spatial superpositions, nanomechanical resonators approaching the quantum regime. They all push on collapse parameters. If objective collapse exists, there's a mass or size scale where interference must die regardless of isolation. So far, the frontier keeps moving without finding a hard wall. That squeezes spontaneous collapse models into narrower corners. Many worlds fans smile, collapse fans adjust rates. The debate stays empirical. Remember this detail. What you call an outcome is a stable pointer state redundantly recorded in many fragments of the environment. Photons, phonons, scattered particles. Quantum Darwinism argues that objectivity arises when multiple observers can independently sample those fragments and agree on the result without disturbing it. Consensus becomes a property of redundant records, not a metaphysical given. That's a clean bridge between lab measurement and everyday facts. The pattern is the same one we've been tracking. Measurement isn't a passive window, it's an intervention that defines what's real for whom. Entanglement is the glue, decoherence is the knife. We can compute the cuts, harness them for computation and sensing, and certify the results. But every solution recasts reality as process. If minds matter here, not as magic causes, but as agents setting the questions, then the next step is unavoidable. What are minds actually doing when they see a world? Fact 7. Your consciousness might be a controlled hallucination. We just used agents set the questions in quantum labs. Let's talk about the agent. Your brain isn't a camera, it's a prediction machine that guesses the causes of its inputs and updates when it's wrong. That's predictive processing, perception as controlled hallucination, kept in line by error signals. The world you experience is a model, negotiated, not recorded. Start with the loop. The brain generates top-down predictions about what the next sensory volley should look like: edges, sounds, proprioception, interoception. Bottom-up signals carry prediction errors, the mismatches between expectation and incoming data. You can reduce error in two ways: revise your beliefs perception, or change the world or your body to make the data fit action. That's active inference. You move your eyes, shift posture, sample the scene, all to harvest evidence that confirms your model or forces it to change. Why this matters: certainty is a feeling, not a fact. Confidence tracks the precision your brain assigns to predictions and errors. High precision on priors, low precision on errors. You'll perceive what you expect even if the data disagree. High precision on errors. Your model becomes volatile, noisy. The dial settings of precision shape your reality. Watch for the demos, the rubber hand illusion. Stroke a fake hand in sync with your hidden real hand and your brain adopts the fake as its own. Change blindness. Swap big visual features across saccades and people miss it because the model already knew what was there. Binocular rivalry. Feed different images to each eye. Perception flips because the brain can't settle on one consistent cause. Placebo and nocebo. Beliefs about a treatment modulate pain and physiology via top-down control. These aren't glitches. They're how inference works when priors and evidence trade weight. Here's the glue to the rest of our pattern. In physics, measurement was inference under constraints. In minds, perception is the same game, inferring hidden causes from ambiguous signals with limited bandwidth, energy, and time. Entanglement glued subsystems. Here, priors glue sensations into objects. Decoherence selected pointer bases. Here, attention sets precision, selecting which errors get to reshape the model. The knife is different, but the logic rhymes. Now the machinery. Hierarchies of generative models stack, from low-level features up to objects and situations, all the way to narratives about the self. Each level predicts the one below, errors flow upward. Interoception signals from the body anchors affective states. Your mood is the brain's story about bodily causes, shift interoceptive precision, and the world's color changes. That's why anxiety tunes you to threat and why calm broadens your perceptual hypotheses. Here's a detail people miss. Action participates in perception by controlling sampling. Saccades are experiments, quick eye movements that place high-precision receptors where predictions are uncertain. Motor commands carry predicted sensory consequences, efference copies, and the system subtracts them from actual input. That's why you can't tickle yourself. Your brain already predicted the touch, so there's no surprise. Perception is model testing at millisecond scales. Okay, but where's you in this? The self is a bundle of predictions about the causes of sensations attributed to a single body. Proprioceptive priors, interoceptive priors, autobiographical priors. Together they generate a stable, actionable center. Anil Seth calls it the most familiar hallucination. The self as the brain's best-guess control model for keeping a living body within viable bounds. It's not fake, it's functional. Now the failures that teach. In psychosis, precision may be misassigned. Too much weight on prediction errors can make noise feel like signal. Too much weight on priors can turn beliefs into unshakable perceptions. In depersonalization, self-model predictions lose grip on interoceptive grounding, and the world feels unreal. In anesthesia, predictive hierarchies decouple and precision control collapses. Consciousness fades when error can't propagate and models stop updating as a unified whole. Notice what this reframes. Seeing is believing flips to believing guides seeing. Expertise isn't just memory, it's priors sculpted to expect the right patterns. That's why radiologists spot faint tumors and chess masters chunk positions. Accuracy is expensive, energy, time, data. Confidence is cheap, raise prior precision. Institutions build instruments and protocols to push precision toward evidence and away from expectation. Science is predictive processing with accountability. Here's the empirical core. Predictive coding signatures show up in cortical laminae and rhythms. Mismatch negativity in EEG marks surprise. Pupil dilation tracks precision shifts. Active inference accounts for eye movement statistics. Computational psychiatry links symptoms to precision mistuning. These aren't metaphors drifting free. They're models with measurable consequences. Tie it to our earlier arrows. Memory formation is an entropic act. Writing robust priors burns energy and leaves traces. The sense of temporal flow arises as the system predicts trajectories and updates with asymmetric access to records. We have stable priors about the past, not the future, because records exist only from irreversible processes. Your brain rides the thermodynamic arrow by harvesting low entropy to reduce prediction error. And the kicker, if senses are inference, experiments are institutionalized inference, shared priors, explicit error models, public updates. We aren't escaping hallucination, we're corralling it with better calibration. That's the real humility. The world you experience is a controlled hallucination, but the control can be tightened. So what's the smallest certain building block of reality if even perception is negotiated? Spoiler, there isn't a smallest stuff, only fields and the excitations we call particles. Matter becomes behavior and substance becomes structure. Fact 8, the universe isn't made of stuff, it's made of fields. So if minds are inference engines, what are they inferring? Not marbles and billiard balls, fields. In modern physics, the fundamental entities aren't pellets of stuff. They're continuous fields spread through space and time. A particle is a localized excitation, a ripple that shows up as a click in a detector. Electrons are excitations of the electron field, photons of the electromagnetic field, quarks and gluons of their own fields. Even the Higgs is a field whose non-zero background value lets certain excitations behave as if they have mass. Why this matters? Solidity is choreography. Your chair feels stiff because electromagnetic fields between atoms resist compression. The atoms themselves are bound states sustained by quantum fields exchanging quanta. Push anywhere and you're pushing on patterns. The everyday intuition, objects as self-contained lumps, crumbles. Matter becomes behavior. Watch for 3 anchors. First, gauge theories, the deep symmetries that tell fields how to couple. Demanding local gauge invariance of the electron field forces the existence of the electromagnetic field with exactly the right interaction structure. Generalize and you get the non-abelian gauge fields of the weak and strong forces, SU2 and SU3, with their self-interactions and confinement. Second, symmetry breaking. At high energies, forces unify in neat symmetries. As the universe cools, fields settle into asymmetric ground states. The Higgs field picks a direction in internal space, giving W and Z bosons mass while the photon stays massless. Third, renormalization, the scale dependence of couplings. What looks like a constant strength at one energy runs with the probe scale because vacuum fluctuations dress charges and fields. Notice the pattern we've been tracing, properties from relations. Charge, mass, spin, these aren't tags glued onto nuggets. They're how excitations transform under symmetries and how they respond to other fields. Spin is representation theory of rotations. Mass, for many particles, is interaction with the Higgs background. Even free space isn't empty. The vacuum is a structured state of all fields, seething with correlations that affect measurable quantities, like the Lamb shift and anomalous magnetic moments. Here's the subtlety. Renormalization isn't just a mathematical cleanup. It's a physical statement that descriptions change with resolution. You integrate out high-energy details and get effective theories with new parameters and operators that encode the influence of what you've hidden. Universality says wildly different microscopic models can flow to the same long-distance behavior. That's why quantum field theory works across scales, from condensed matter to particle physics. It's a language of patterns that survive coarse graining. Okay, but why these fields, these symmetries, these couplings? The standard model is dazzlingly predictive and strangely contingent. We write the most general, renormalizable Lagrangian consistent with observed symmetries and recover an enormous range of phenomena. Yet we still ask, why SU 3 times SU 2 times U1? Why 3 generations? Why those mass hierarchies and mixing angles? The math sings, the choir list feels arbitrary. Here S where the Higgs helps and haunts. Before 2012, mass came from the Higgs mechanism in theory after the Higgs boson's discovery cemented that fields give mass by interaction. But the Higgs potential's parameters, including the vacuum expectation value and self-coupling, are inputs. The vacuum seems metastable near the edge of stability at high energies. Coincidence? Hint, we don't know. Again, fine-tuning whispers. Tie back to our dark sector headaches. If everything is fields, dark matter might be a field excitation we haven't tuned to yet, axion-like, sterile-like, or something more exotic. Or the effects we ascribe to energy in vacuum are geometry's response to field zero points we don't understand. Either way, the language stays field-theoretic. Unknown excitations, new symmetries, hidden sectors. Now the punchline for stuff. A crystal's solidity comes from collective modes, phonons that aren't particles in the vacuum but emerge from many-body order. Superconductors break electromagnetic gauge symmetry effectively and give photons a mass inside the material. Magnetic fields are expelled by the Meissner effect. That's a lab-scale echo of the Higgs story. Different substrate, same principle. Fields plus symmetry breaking rewrite what particles exist and how they move. Remember this detail because it's the bridge to spacetime itself. Entanglement isn't an add-on to fields, it's their native texture. Cut space into regions and the vacuum exhibits area law entanglement entropy. Correlations scale with boundary area, not volume. That's why tracing out the outside makes the inside look thermal near the boundary. In gauge theories, edge modes live on the cut, carrying the bookkeeping that keeps gauge invariance intact when you separate regions. The boundary remembers the bulk. What's crazy is how this flips map and territory. The equations, symmetries, conservation laws, renormalization flows predict exquisitely. But the ontology shifts from things that have properties to structures that persist under transformations. It lines up with our earlier moves. Non-local ties over local facts, observer-dependent slices over universal. Now, arrows from boundary conditions over dynamical decrees. And the open question slides into view. If fields make matter and forces, is space the stage or another actor? Hints from holography and quantum gravity suggest geometry might itself be a code woven from entanglement patterns in some underlying quantum system. If that's right, then even the field picture is effective, astonishingly successful, still not final. In other words, the chair is vibration in fields, and the field is, maybe, a shadow of information stitched into something deeper. Fact 9, space might be quantized, or emergent. We just said fields might be shadows. Here's the deeper suspicion. The stage itself, space and time, may not be fundamental. Either it's grainy at the smallest scales, or it's not stuff at all, just bookkeeping for correlations in an underlying quantum system. Start tiny. There's a natural unit where all our constants collide. The Planck length about 1, 6 times 10^35 meters. We don't have a microscope for that, but our equations hint that below this scale, the smooth fabric of geometry stops making sense. Push more energy into a smaller region to probe smaller distances, and you curve spacetime so hard you'd form a black hole, hiding what you tried to see. That's the operational wall. Attempts to measure shorter distances bounce off gravity. Two broad strategies emerge. One says spacetime has atoms. Loop quantum gravity quantizes geometry directly. Areas and volumes come in discrete spectra built from spin networks, graphs whose edges carry two labels. Geometry becomes combinatorics, nodes and links, not coordinates and metric. Evolve those graphs and you get spin foams, histories of quantum geometry. Smooth space is a large-scale average, like fluid behavior emerging from molecules. The other strategy says spacetime is emergent from entanglement. Holography, most precisely realized in AD-SCFT, equates a gravitational theory in a higher dimensional de Sitter spacetime with a non-gravitational quantum field theory living on its boundary. No gravity on the boundary, full gravity in the bulk, yet they're the same physics. The boundary theory's entanglement structure maps to bulk geometry. The Ryu-Takayanagi formula says the entanglement entropy of a region on the boundary is proportional to the area of a minimal surface hanging into the bulk. That's a geometric law built out of quantum information. Watch what to look for. Tensor networks, MERA and friends, construct many-body quantum states with a layered web of entangling gates that looks suspiciously like a discrete hyperbolic space. Distances in the network track correlation patterns. Minimal cuts through the network compute entanglement entropies the same way minimal surfaces do in AD-S. It's not proof, but it's a working toy model of geometry from entanglement. Then there's equals EPR, the conjecture that entangled pairs, EPR, are connected by non-traversable wormholes, ER. Don't picture sci-fi tunnels. Think of it as a statement that entanglement and connectivity are two faces of the same structure. In AD-S, we can make this precise in certain setups. Glue two black holes in a thermofield double state and the bulk looks like a wormhole. The punchline isn't travel, it's bookkeeping. Correlations stitch the manifold. Now, why this matters to the pattern we've been building. Non-local ties in quantum theory refuse to respect distance. If geometry arises from those ties, then far apart is secondary, a summary of weak correlation. The map might be more fundamental than the territory. Constraints and entanglement are primary. Space is the picture we draw to compress them. Here's a subtlety. Holography is cleanest in AD-S, a negatively curved sandbox. Our universe looks closer to de Sitter with positive curvature due to dark energy. There's no crisp DS-CFT dictionary yet. People push de Sitter holography, cosmological wave functions, and quantum error-correcting codes that capture how the bulk resists localized erasures. Another hint that geometry is a code protecting boundary information. But the full translation for our sky is unfinished. Loop-style discreteness and holographic emergence might sound like rivals, but they could be complementary. One quantizes geometry's kinematics. The other derives geometry as a phase of an underlying quantum system where entanglement patterns obey area laws. Both predict area scaling for entanglement entropy. Both elevate relationships over points. What could we actually measure? Planck-scale discreteness might leave imprints. Slight dispersion in high-energy gamma-ray bursts, noise in interferometers beyond known sources, or modified black hole spectra. So far, no clean signal. On the holographic side, we test the duality by computing bulk phenomena from boundary field theories. Quark, gluon plasma viscosities, thermalization, chaos bounds, page curves for evaporating black holes via islands. Each success says the dictionary's real, even if our universe is AD-S. Remember this detail. Cut a quantum field theory into regions and gauge constraints, leave edge modes living on the boundary. Those modes carry the information needed to glue regions back consistently, like stitching instructions on a seam. In gravity, something similar seems to happen. The degrees of freedom that keep diffeomorphism invariance honest live on boundaries and horizons, and their counting matches black hole entropy. Boundaries remember the bulk, because the bulk is a story about how boundaries fit. What's crazy is how many languages converge on emergence. Condensed matter uses renormalization to show universality. Different micromodels, same macro laws. Quantum error correction shows how logical information can be delocalized and robust, exactly what you want if spacetime should survive small mistakes. Tensor networks turn entanglement into geometry. Gravity plus quantum fields insist horizons encode areas as entropies. The chorus is loud. The pattern returns, sharp as ever. What looks continuous may be built from discrete informational bits. What looks local may be an optimized representation of non-local constraints. We started with invisible matter and energy, moved through non-local ties and relative time, and now even the stage is suspect. Pull back. How do we reconcile neat math with messy anomalies? The constants we thought were fixed may be drifting signposts in a landscape we barely map. Fact 10, constants aren't constant. We've been trusting the stage directions, CH/G, E, as if they're engraved in bedrock. But what if the rules have dial settings and the dials drift? Start with the fine structure constant alpha. It's dimensionless, no units to hide behind, and it governs how strongly light and charged particles interact. Change alpha slightly, and atomic spectra shift, chemistry rewrites, stars forge different elements. This isn't cosmetic. How do we know whether alpha budges? 2 rulers. In the lab, atomic clocks compare transitions with extreme precision. Put identical clocks at different gravitational potentials and they drift, relativity corrections we already covered. Beyond that, ask whether ratios of different atomic frequencies wander over time. So far, within current precision, lab constraints say no obvious drift, but sensitivity keeps improving. In the sky, quasar absorption spectra let us read off energy level spacings from billions of years ago. Light passes through intervening gas. Atoms in those clouds imprint fingerprints. If alpha were different then, those fingerprints shift. Teams using high-resolution spectrographs have both reported hints of spatial dipoles and found null results when systematics are tamed. New instruments like espresso tighten the leash to parts per million. The pattern right now. If alpha varies, it's tiny. So tiny that we're arguing over noise floors and line calibrations. Here's the subtle bind. If a dimensionless constant varies, something physical is changing. But which thing varies depends on how you parametrize your theory. If alpha drifts, you can trade that story for one where E changes or C changes. Units make that ambiguous. The only safe statement is about dimensionless combos. That's why alpha is the right battlefield. Why this matters goes beyond alpha. If constants vary, either we're seeing a new field, call it a scalar that slowly rolls and couples to sectors like electromagnetism, or we're admitting that our constants are environmental values set by boundary conditions. In the first case, the scalar mediates a fifth force. Then you have to hide it with screening mechanisms so it dodges solar system tests and lab searches while still nudging cosmology. Chameleon, Symmetron, Weinstein, each tries to be loud on cosmic scales and quiet in your basement. In the second case, you drift toward anthropic selection. In a multiverse landscape with many vacuum configurations, different regions realize different constants, and observers arise where the values allow long-lived structure. That explains smallness by survivorship, not dynamics. Watch for anchors outside alpha. The Oklo natural reactor, uranium deposits that self-sustained fission about 2 billion years ago, locks in nuclear resonance conditions. If alpha or the strong coupling had drifted much, the reaction wouldn't match the isotopic leftovers we see. Oklo becomes a time capsule constraining change to tiny windows. Meteorites do similar duty via long-lived beta decays. Pulsar timing and spectral lines in gravitational potentials test whether constants depend on environment, potential equivalence principle violations. Notice the recurring fine-tuning pressure. Dark energy demanded a value so small we whisper 1 in 10, 120. The Higgs mass begs for delicate cancellations. Alpha sits in a narrow, life-friendly band. Shift it a few percent and you wreck stellar nucleosynthesis or molecular stability. We keep landing on needles in haystacks. You can take that 2 ways. Either there's hidden symmetry or dynamics forcing these values, and we just haven't cracked the code. Or there's a distribution of possibilities, and we live in a rare patch because that's where questions can be asked. Here's the uncomfortable technical detail. If a scalar field drives variations, coupling to electromagnetism tends to bleed into couplings to matter masses, inducing composition-dependent forces. Then Erasure-style torsion balance experiments, lunar laser ranging, and atom interferometry become snipers. So far, they're deadly precise. Surviving requires tuned couplings or screening that flips on with density. Every escape hatch adds epicycles. Yet constants aren't constant isn't only about drift. Some run by construction. In quantum field theory, couplings depend on energy scale through renormalization group flow. Alpha itself increases with energy. The strong coupling decreases, the reason quarks are freer at high energies. That running is agreed on and measured. The new claim would be running with cosmic time or environment, not probe energy. So the question is, do we see scale dependence beyond the renormalization group? Right now, no clean signal, just better bounds. Tie this back to our pattern. Fine-tuning showed up with dark energy. It echoes here. If different regions or epochs host different effective constants, then physics might be regional. Laws become a menu with fixed grammar but variable choices. Same syntax, different sentences. That reframes explanation from deriving a single number to constraining allowed distributions and measuring where we sit. Remember this, if constants vary, clocks, rulers, and calibrations become participants, not bystanders. Distance ladders, lensing calibrations, nucleosynthesis yields, all assume the same constants then and now. Relax that and some tensions could soften, others sharpen. The Hubble tension, lensing's low clustering amplitude, these could be whispers or mirages. Institutions are already testing with cross-checks that don't share assumptions. And the bridge forward, when categories wobble, life appears in places we didn't expect. If rules have dials, selection and emergence start to matter more than essence. Which brings us to the next shock. Our probabilities for life's first step were way off. Fact 11. Life's origin cheats the probabilities we use. We've been treating constants like dials. Here, S where the dial setting seems to exploit physics. The textbook intuition says life is astronomically unlikely, random soup, impossible odds. But in real chemistry under real planetary conditions, the probability story flips. Life rides gradients, catalysts, and cycles that bias outcomes long before genes exist. Start with the bottleneck, getting from simple molecules to systems that store information, copy with variation, and harness energy. The RNA world pitch says a single polymer both stores information and catalyzes reactions. That's elegant but hard. RNA is fragile, its bases are fiddly to make, and templated copying without enzymes is finicky. So origin of life research broadened. Maybe metabolism came first, reaction networks that harvest energy and concentrate organics, with genetics arriving later as bookkeeping. Watch the environments that do work for you. Hydrothermal vents push alkaline fluids rich in H2 through iron, nickel sulfide walls into mildly acidic ocean water. That creates natural proton gradients, batteries across microscopic pores lined with catalytic minerals. Co2 plus H2 becomes organics via surface-bound steps, not random soup. You get compartments, gradients, and catalysts for free. That's selection pressure on chemistry, not on organisms. Autocatalytic sets are the next lever. In a big enough reaction hypergraph, some subsets catalyze each other's formation. Once a small seed appears, flux through that subnetwork grows, hogging resources and outcompeting rival pathways. That's selection without genes, structures that make more of themselves win. Add compartmentalization, fatty acid vesicles that form spontaneously, and you've got protocells, microreactors that grow and divide when they accumulate enough amphiphiles or when osmotic stress forces fission. Here's a detail people miss. Energy flow plus constraints can ratchet complexity without aiming. Chemiosmotic gradients across thin mineral barriers resemble the proton motive forces in modern cells. ATP synthase is a rotary motor driven by protons. At vents, the gradient is external. Early systems could piggyback environmental gradients before internalizing them behind lipid membranes. That solves the chicken, egg of motors need membranes. Membranes need motors, by using geology as an exoskeleton first. RNA doesn't have to do it alone. Mixed nucleic acid worlds, RNA with short peptides, show synergy. Peptides stabilize folds and promote catalysis. Ribozymes foster peptide bond formation. Short, sloppy polymers can copy parts of each other with error rates that are high but survivable if cycles periodically prune the herd. Wet, dry cycles on mineral surfaces drive condensation reactions, linking monomers into longer chains, while UV light and selection filters trim dead ends. Noise plus cycles yields a directional push. Notice the pattern we keep hitting. Far from equilibrium systems self-organize when driven. Stir in a steady energy gradient, add a medium with catalytic structure, let feedback loops amplify productive pathways, and order appears faster than random combinatorics predicts. Improbable calculations that multiply independent coin flips miss the correlations imposed by surfaces, gradients, and network effects. The search space isn't the abstract set of all molecules. It's the subset reachable by lawful flows that keep paying their energy bills. What to watch in the lab? Autocatalytic RNA ligase networks that grow more complex under serial dilution. vesicles that grow by stealing lipids from neighbors, then divide under shear, enacting primitive competition. Mineral-promoted reduction of Co2 to acetate and pyruvate, core pieces of central metabolism, without enzymes. Ribozymes that copy short sequences and improve under selection. Chemical gardens that produce membranous tubes and gradients in a beaker. Each result isn't life, but each removes a supposed miracle and replaces it with a mechanism. Information enters early as constraint, not meaning. A replicator's sequence is a control knob on reaction rates. Even without perfect heredity, biases accumulate. Some sequences survive cycles better, some compartments retain catalysts longer. Information ratchets because the environment deletes the losing variants. Evaporation, diffusion, and pH swings are ruthless editors. That's selection before Darwin, differential persistence of compositional states under periodic forcing. Here's the uncomfortable elegance. Life looks like entropy's side hustle, a machine that accelerates energy dissipation by building structures that channel flows more efficiently. Autocatalytic metabolisms spread because they eat gradients faster. Replication spreads because it copies those structures. Complexity grows where it helps the system dump free energy into heat under constraints. That's physics. Tie this to our wider thread. Space may be emergent from entanglement. Organisms emerge from reaction networks nudged by geochemistry. In both, micro rules and boundary conditions generate macro regularities that feel designed but are discovered by flows. Cheating probability is really exploiting structure. The universe isn't rolling independent dice. It's solving constraint problems with whatever patterns fit. Now the bridge. If life rides computation like ratchets in chemistry, then thinking systems ride computation in matter. Which brings the last step into view. Reality behaves like it's computing, but not the way your laptop does. We're back to information with a price tag and black holes acting like storage devices. The universe computes, but the substrate and the rules aren't ours. Fact 12, the universe computes, but it's not your computer. We've been circling one idea all along. Reality keeps acting like information with constraints. Here's the clean version. Information is physical. Changing it costs energy. That's Landor's limit. Erase 1 bit, pay at least kT ln2 of heat. Your laptop leaks it as warmth. Nature pays everywhere, neurons, crystals, black holes. The rule isn't a metaphor, it's a bill. Why this matters: if information carries energy costs, then computation isn't just silicon flipping bits. It's any lawful transformation of states that compresses, propagates, and discards information under constraints. Chemical networks compute next concentrations. Fields compute next field values. A falling rock computes a geodesic. None of this runs on a clock in the sky. The clock is the dynamics. Watch 3 anchors. First, thermodynamics of information. Maxwell's demon tried to sort molecules and beat entropy. The loophole closed when we priced memory resets. Measure, store, act, erase. The cycle only works if the entropy cost shows up in memory handling. Every free lunch hides an information dump. Second, black hole bookkeeping. Bekenstein and Hawking forced a wild equation on us. The entropy of a black hole is its horizon area divided by 4 in Planck units. More area, more bits. That means horizons are storage devices with densities nobody can match. Hawking radiation makes them glow thermally, but the temperature is gravity's surface acceleration. As holes evaporate, their radiation must somehow encode the information about what fell in or unitarity fails. The modern picture uses quantum extremal surfaces and islands to get page curves that bend the right way. Translation. Gravity plus quantum theory acts like a giant error-correcting code, spreading information so it isn't lost even when local pieces look thermal. Third, chaos and scrambling. Drop a qubit's worth of disturbance into a many-body system or a black hole and correlations spread fast. Out-of-time order correlators shrink. The system forgets local details while hiding them non-locally. There's a universal bound on chaos growth set by temperature. Black holes saturated, the fastest scramblers we know. Notice what we are not saying. The universe isn't a digital computer stepping through instructions on a global clock. Cellular automata are cute analogies, not blueprints. The substrate here is quantum and continuous at effective scales, with error correction, renormalization, and symmetries shaping what can and can't happen. Computation is a lens, a way to talk about constraints, resources, and trade-offs across systems. Here, S where holography sharpens it. Bulk geometry in ADS behaves like a code that protects boundary information. Lose a chunk of the boundary, and you can still reconstruct much of the bulk. Logical operators have many equivalent physical representations. That's the hallmark of error correction, not coincidence. Even shock waves in the bulk map to simple operators that become highly complex on the boundary with time. Complexity grows like a computational cost. Some proposals even tie wormhole volume to computational complexity. Take that literally or not, the pattern is clear. Geometry tracks circuit-like properties of quantum states. Now fold in measurement, mines, and arrows. A measurement is an information flow with amplification and erasure, compressing many possibilities into one recorded outcome. Landor guarantees heat. Memory formation in brains obeys the same bill. Prediction error is information you can't compress with current priors. Learning is changing the codebook so future inputs compress better. That's why learning costs energy and produces heat. The arrow of time is the universal bias toward states that compress past data and discard microdetails into environments you won't recover. Entropy rises because forgetting is cheaper than perfect bookkeeping. Okay, but why should laws look simple? Because simple descriptions are the compressions that survive. Symmetries are shortcuts. They say many different microhistories project to the same macro description. Conservation laws are compression guarantees. Renormalization is code refactoring across scales. Integrate out high-energy bits, keep effective rules that compress long-distance behavior. Universality tells you very different microcodes lead to the same macrosyntax. Here's a subtlety that sounds philosophical and turns practical. When we say the world is lawful, we're saying there exist short descriptions that predict a lot. Kolmogorov-style compressibility is the heartbeat. Where you can't compress, chaotic weather, turbulent flows, you switch to statistics because that's the compression that works. Where you can, you write Lagrangians. The bridge to black holes closes the loop. The no-hair theorems say mass, charge, spin label the macrostate, everything else is hidden. The entropy area law says how much is hidden. The information paradox forced us to confront whether the universe keeps perfect books. The island result says it does, but only if you let entanglement weave through spacetime in code-like ways. That's the computation we mean, not digits flipping, but constraints and redundancy shaping what persists. So where does that leave us? Reality looks like a constraint satisfaction process that favors compressible patterns, pays energy to erase, and writes its ledgers on horizons, memories, and records. From lab measurements to mines to black holes, the same accounting rules apply. You're not living inside a simulation, you're living inside a lawful compression. Synthesis, the pattern nobody expects. Here's the through line. Every fix that made measurements line up replaced substances with relationships, absolutes with contexts, things with processes. Dark matter is an absence defined by its pull, dark energy a pressure defined by its push. Entanglement replaces separate objects with joint constraints. Relativity turns now into a slice you choose. The arrow of time comes from boundary conditions and coarse graining. Measurement is the act that writes which properties are real for whom. Fields turn matter into behavior. Spacetime starts to look like a code compiled from entanglement. Notice how cleanly the 7 core beats rhyme. Invisible matter and energy act like external constraints you feel but don't see. Non-local ties make between a bookkeeping choice, not a fact. Relative time makes when a geometry problem. The entropic arrow points one way because we began improbably ordered and then kept discarding fine details into environments we don't recover. Observer effects say records are made by cutting systems, and cuts change what's stable. Field ontology says properties are how excitations transform and relate. Emergent spacetime says geometry is the ledger of correlations, not the warehouse of stuff. The tension isn't that institutions are confused, it's that our instruments are precise enough to force choices our intuitions hate. The mysteries are narrow, deep, and real. We can aim telescopes to count lensing arcs and watch missing mass curve light. We can time satellite clocks and rescue maps by subtracting gravity's stretch. We can violate Bell inequalities and still not signal faster than light. We can cool superconducting qubits and watch fringes that narrow collapse theories into tighter corners. Precision outran interpretation, and interpretation has to catch up. Now turn the camera around. Minds sit inside all this like tiny inference engines playing the same game. Perception is controlled hallucination guided by priors and prediction error. Experiments are collective priors with transparent error bars and agreed update rules. We're predictive systems inside a predictive universe, compressing data with laws that are themselves compressions that survived. Of course, we discover codes and constraints we're built to. One contradiction we left open on purpose is loudest here. Unitary quantum evolution is reversible and preserves information, but the arrow we live by is irreversible and forgetful. The modern fix puts the arrow into the cut. Subsystems see entropy rise as they lose access to phases, while the universe keeps perfect books. That doesn't close the philosophical itch. It locates it precisely. And the final twist loops to geometry. If the vacuum's entanglement obeys area laws, if horizons carry entropy proportional to area, if bulk geometry acts like a code that protects boundary information, then space is the scaffolding our best compressions draw around consistent correlations. You don't live in a cloud of marbles. You live in a web of permitted relations that masquerade as locations, moments, objects, and causes, because that's the shortest description that works. You wanted a single key. The pattern is the key. Relationships over essences, constraints over substances, emergence over foundations. Once you see that, the pieces stop competing and start composing, and your reality becomes a tighter, shareable story. That's how you make this viral. Hook with the paradox, tighten the payoff, and leave one itch unscratched for comments. That's the pattern nobody says out loud. Reality isn't made of things you witness. It's the compression your best measurements can barely keep straight. If you want the deep version, watch the next episode where I trace one paradox end to end, non-locality versus causality from Bell tests to black holes. Subscribe for the full series and drop your favorite impossible fact below. We'll dissect it live. If you learned one thing, share this with the most skeptical person you know and ask them which fact they don't buy.